Let's now do some practice questions on references. Please take a closer look at this program and try to guess the output of it. We have a variable x equal to 10, y equal to 20, then we have a reference z which is equal to x. We do z equal to y, then we do z equal to z plus 5, then we print x, y, z, all of them. What will be the output of this? See, particularly this line, what happens here is when you do z equal to y, references are bound to only once, right? So z and x, they are now labeled to the same location. When you do z equal to y, the reference does not change to now refer to y. What now happens is the value at this reference is changed. The value of the location for which this z is a label, the value at that location changes to whatever value is y having. So what now happens, x and z, since they both are same location labels, they both change to 20, right? Now we are doing z equal to z plus 5, so x and z both will change to 25. So the output of this program is going to be 25, and this y is never changed in this program, so it's going to remain 20, and z is also 25. Let's now take a look at this question and try to guess the output of this program. So we have this function which is returning a reference. And what are we returning? We have a local static variable x whose value is 10 and we are returning x. In the main function, whatever it returns, we have a reference to the return type, return value. Now we change this reference y equal to 20, and now what we do is we print return value of function. So what should be the output here, 10 or 20? The output is here going to be 20. What happens here, these static variables, they stay there even after the function call is over, right? And we are returning a reference to the static variable, right? So y is going to refer to the static variable where this x is stored, right? So it has value 10, label x, now we have one more label y. Now when we change y equal to 20, this is changed to 20, right? Because y is referring to the same thing. When we discussed variables, we discussed that in case of static variables, this line is executed only once, right? Initialization happens only once. And then whatever changes you make, those changed values are used in the further calls. So in the second call, the changed value 20 is going to be returned, right? Because we went to this location and we changed this to 20 using a reference. Right, so this x is changed now to 20, and in this call we are going to get the output as 20. Now please remember one thing, we should not return reference to non-static variables, non-static local variables. If I remove static from here, then this program becomes troublesome. Why? Because these local variables, they exist only when the function call is made, and when the function call is over, their existence is not guaranteed, they are invalid now. Right, so once the function call is over, and if I am trying to have a reference to a variable which might not exist now, it's going to be problematic. Let's now take a look at our third question. Here we have two strings s1 and s2. S1 is GFG space, then s2 is courses. Then we have r value reference because we have two ampersand here, right? Which is s1 plus s2. Now we are doing s3 equal to welcome to and then s3 appended. And at the end we are printing S3. So please pause this video and try to guess the output. The output of this program is welcome to GFG courses. This program compiles and runs fine. As we have discussed earlier, double ampersand means R value reference. It can refer to R value, and this expression is an R value. We typically use it on the right side of the assignment, right? So we have a reference to this R value, and then when we prepend welcome to this R value, right, this also works. And when we print S3, we get the output as welcome to GFG courses.